Yes, we start with definition of resources. Well, resources uh, in the context of digital information. So and here the definition of resources is very generic. It can be a web page, a specific part of a element of a web page, collection of web pages, or even objects which are not accessible via the internet. And the important point is that we should be able to name these resources. And for this, we need, or we will use, uniform resource identifier. So you all know what this is. This is a standard for naming in the internet. And your uniform resource locators are sets of a more generic entity, which is called URIs, obviously. So, and the important thing about identifiers is that they are used to name objects that possibly are not retrievable at all. So they're simply used for naming. So we come to this first constructs for representing atomic knowledge pieces. So where we describe a resource. So now we will come to examples of what resource is. But resources, they have properties. And properties can be of terminal character, so a value, or a property can be another resource. In any case, and here is an example what we mean of constructing this resource description. So if you take my web page, well, that's just a static information, but so we can name well, the different objects on them. So like my name would be or URI would in this case refer really to me as a person. And so here we have two types of relationships. So there is a relationship between digital objects, so like web pages. But we also have another semantic relationship of organizations and individuals. So me as an individual, so I have a property of being employed by somebody. So later on we will come to different types of properties. So there are the directional properties. So that's that company also may have a property employee. Organization may have a property employee, which refers back to concrete employees. But here is the basic concept. So first we have two digital resources, and they are referred by, well, they are retrievable. So these URIs, they are also locators. So you can retrieve this digital object. But then we may have on a site a description of semantic relationship between the objects referred or described in this digital resource. So in this similar fashion, in this similar fashion, we may populate this description with different properties. So again, so this is an example of characterizing this digital resource with the property as birthday, so the time of instantiation of this web page. And the same property can be applicable even to the object, to the resource for which this uh, digital resource is created for. So for a person. And in this case, so this is an example of a property that terminates with concrete value. And you can and extend or enhance the semantic description of the digital world by adding new properties and creating this kind of bidirectional links between objects which are not retrievable. And so let me see. Let me come back to this. Maybe in the meantime you can clarify what you mean is the difference in your opinion. Well, here is the where is it? Yeah, so you populate this description of objects there with different properties as you please as a knowledge engineer, and then you should you basically record them and store in a kind of storage, which later on becomes your knowledge base. What you can notice, however, so in all these examples, so we have this very, very simple format. So resource, property, and a terminal, either a terminal symbol or another resource. So, and in this case, as I said, we are talking about creating atomic statements and for describing resources, which in general are referred to subject, predicate, object. So where predicate is the property. So referring back to your question in Zoom, so it's property here is again. So I don't fully understand the difference between what you mean logical and AI terms. Are the terms you're showing used only in the context of AI? No, they are not used in the context of AI. So that's, I mean, they are also used in the context of logic and reasoning, but which is part of AI. But again, maybe I'm not fully on. Do you have opinions about this question? Maybe I kind of miss the. I mean, I'm asking the audience. Huh? Again, so now well, yeah, I read it, but I mean, it depends what you mean by AI. I mean, it's definitely part of symbolic AI. So where you represent the knowledge and you do inference. So that's a practical application of this type of representation and all these definitions within the scope of AI. So we are not talking about neural networks, AI, or part of AI, but rather construction of logical sentences and in general sentences representing knowledge. Yeah. So maybe I again, let me see. Yeah, okay, good. And again, practically, describing resources is has a very intuitive analogy to filling a questionnaire. So your task is to describe describe something in a standard format, and you just at this very moment you're restricted to this short representation format of subject predicate object, and in this case it's very similar to filling a questionnaire. So age is terminal. So or basically, I mean, we are describing a resource, me in this case. So me has age and then particular age. Me has employer, and then you indicate who is employer, etc., etc. And again, so you see here, so different usage. So your object in a way can also be a resource, so a retrievable resource. It means that later somewhere in your database it should be specified what it is. Or it can be a terminal, so a URI. So now we come to this again subtle definition of concepts and in the scope of resource identification. So we want to name resources, name properties, but we also want to name concepts somehow. So if we want to represent this statement with the subject John, predicate or property loves, and object Mary. So obviously we might have different instances of John, so we need to give it a name. So, and this is done with URI to point into a specific individual. The same goes for the object again. So, out of many possible instances, you need to be specific which instance we are talking about. And then the property. So, property is a concept. So you. So how do we go about it? So how do we name it? Where do we name it? So where do we? I mean, from what I have described before, so this URI, so it's somehow a place in the internet, on the web, which has a digital description of an object. And in the case of concrete objects, so that's understandable. So, for example, I have a web page. But what about properties? So, what do we need for referring to properties or predicates? We need a special database, basically, where all these definitions are present and somehow interpreted. So remember, I want to connect to what we discussed last time about given semantics. So agreeing on the meaning of everything. So in a standardized manner. So instead of kind of creating the, direct interpretation, creating interpretations of different phrases, which might be difficult, but again, referring to, for example, present ChatGPT, it is possible. So that's how I mean, this big machinery makes this link between whatever you write in a natural language is somehow interpreted by this big model. So the uh, another way of giving semantics is to agree on some standard interpretation. And then later on, we will see that this will be a part of ontologies. Ontologies is a knowledge base or is a base which defines the meaning in a standardized way. So what love is. So with all the properties and who can be in relation in this particular relationship. So some restrictions. So relationship to other predicates, etc., etc. So, but and the point is that this property can be defined in many different ways, so depending on the context. Again, so due to ambiguity of natural language, people can mean different things and describe love and well, love maybe is not a good example, but you can load this particular property with different meanings depending on the context, depending on the task you have at hand. And this means that you will have different databases that will describe different interpretations of this property. So they all will have the same label, love, but they might have different combinations of properties and relationship to other predicates. So looking a little bit ahead, so we will have a place in the internet with a collection of definitions, and so we will call them later on ontologies, and they can be many, and they will be publicly available online, so you always can access it. And within this database, you will find a name that actually describes this property, and that is how we will represent this resource description in a machine interpretable format. So now we will go again through the very basic constructs. And the purpose of it is to demonstrate the tools that you will use later on for testing the correctness of different statements. So now we describe this simple resource, a web page, a home page of a person, and it has a property who is the creator of this web page. So the RDF statement is simple. So subject is the page, the property has creator, and so this property is defined in some place. And then you indicate the literal. So there are different ways to describe resources. So this is an XML representation of it. So or serial representation. So you spell out all the fields. So you say that you have this is a schema, RDF, and so that would be your subject, predicate, and object. And then you need to define inside the document. So normally, this knowledge bases or resource descriptions. So these are large XML files. And in the header of this file, so you need to define the naming. So you define the shortcuts, the prefixes, where to find this creator. So like this. So again, just to have some template vision. So in the header of the file, you describe where to take the ontology, how to access the ontology, and under which name it will be accessed. You may define several bases, ontology bases, to describe your resources. And then you specify the subject predicate object constructs in this way. So these are just two simple examples. So what are the difference here? Can you tell me? So there is one important difference, well, which is actually, well, actually the difference is in the naming of the object resource. But we take this simple version. So and I will show you now what tools you can use to parse it. So copy. So there are two tools. So two basic tools that you can use to create and validate your RDF statements and check the correctness of your statements. So one is this RDF validator. So it's part of the World Wide Web Consortium portal. So what do you see here? So let me see if I can enhance, zoom in a little bit. So you paste your RDF statement here in the XML format. And then you can have different options here. You can parse it and ask to represent triples, so subject, predicate, object. So in other words, this construct is called triple. But also you can create a graphical representation, which is very useful. I mean, when you to visualize later on visualize knowledge graphs. So we will now use both of them and see what the output is. So here it is. So this is the triple subject, predicate, object, and it's a graphical representation. So this is tool number one. Good to use. You looking a little bit ahead. For example, quiz 2 will be about creating certain statements and validating it in RDF, RDFS, using RDF and RDFS. And I will ask you to create statement for a certain scenario. So, and you need to show the correctness of your statement. And to show the correctness, so you use one of the tools that I showing you now. So this is the first one, validation service. So oh, yeah, all the information will be available in PDF, so and you can try it online. So there are different um, enhancements of the representation format that are created to simplify life of the developers. And one of them is abbreviated format. So yeah, all parsers understand that. So if you compare this, for example, this statement to this statement, so it is way more compact. So you represent it as really as a triple. Next format that I will ask you um, to parse is yet another way of compact representation of knowledge, which is called N3 or notation 3 format. So it's a non-XML serialization of RDFs. So and this is the difference. Uh, so you can compare. So this is the serial XML format and the corresponding statement in N3 format. And this is used again for more compact and fast description of RDF statements. Oops, sorry. So let us see now on examples how this N3 syntax works. So there are different variants, but again, so they all spelled out on the slides, which will be available in Canvas. So what is important? So all N3 statements are terminated with the period with dot. And normally, so they are described like statement after the statement, so stacked descriptions, one under the other. And again, each statement is terminated by dot. However, N3 assumes further optimization. So if you have some repeated parts, so you may use commas just to specify what is altered in these repeated parts. So if you see here, so we have subject, predicate, object. So subject and predicate is the same, and the object part is different. So in M3 syntax, you use comma for that. So the same goes for alternating the predicate object part. So in this case, you use semicolon to separate it. So what do you see here? So you have the same subject all the way through, and so the colon separates the predicate object part until the very last part where so this last comma means the last semicolon means a new line, And here we have proper format. So subject A, predicate Y, and object Z. So again, so this is just to create abbreviated notation, so for brevity of presentation, because otherwise it's very hard to parse these long documents. Uh, so it's a job of parsers then to unroll it. So now a colon and semicolon can be used all in the same statement. And this, again, so this allows us to create rather complicated list of statements in one line. So what, let's see, let's parse it. So what do we have? So in this statement, so until semicolon, so this part will alternate and the subject will remain same. And within this part which alternates, so we have two variants for the object part of the description, C and D, right? And the same as here. So we have G, which is the last group of statements. For the predicate G, and the object will be alternate to Hij. And the important thing that everything that terminates with dots. So in one sentence, we have created what? 6 descriptions. Next, well, this is interesting. So this brackets indicate yeah, a variable. So it's something that you don't know in advance. So that needs to be so the resolver has to take extra actions on for filling in this blank space with concrete values. I will show you an example very soon. But while being on this line, so let's just parse it. So what do we have here? We have a proper subject predicate object. Moreover, here we have another statement within the space. So it means that this something this object, it will be defined within the next statement, which is specified here. So this is spelled out. So this is a variable so far, so it's unknown. And once again, so everything can be used in a single description, a resource description, which allows for creating of this kind of statements. So let us take now a break, and then I will show you a concrete example with how to describe a story with these statements in an entry format. What we will do, we will create two simple statements. Oops, what? Of this kind. And so the story, so we will have a story, so describing personal life facts, and we will encode it into RDF using N3 statements, as we learned. So this is the story about myself. And so we will describe me as a resource. And so please do the same for your own, so that we can try these two tools that I mentioned. So we will have, well, I will have property gender. So I have mother with certain name, and I have two hobbies. So let's see, what do we have? How do we construct RDF description of the simple facts? We use URIs, and here, at this very moment, it's really irrelevant whether you, this addresses are valid or not. So you can use any, so like any dummy website. So URL to location of your knowledge base. But the important point is that you should have this description somewhere in the internet. So look at here. So later on, so next time, I will show you. So somehow Amazon Web Services doesn't cooperate with me this morning. I cannot log into it, but I have a server, a web server, running somewhere on a public in a public domain, and I have a DNS to it. So, and within this web server, I have different files describing the information about knowledge bases. So one file is called university, so it will contain facts about me as employee of the university, and then I might have another file describing some knowledge about lifestyle. And these two ontologies will be used kind of complementary to each other to create statements reflecting this story. So what we do here, we create N3 statements. Oops. So subject, predicate, object. So the property has gender is taken from the ontology, and as well as naming of myself. So create a similar one. Maybe limit yourself to say gender and to the first three items. So gender, sister, whatever, and a hobby. So three statements in this notation. And again, so to maybe streamline the description, so you can introduce the naming schema. So in the beginning of the file, and then you just use the shortcuts. So and this will be used to avoid typing all the addresses every time. So this is a more compact compact way of describing. So try it out. Notice that you need to have dots at the end of each N3 statement. Yeah, so here, so write this at prefix ontology one. So any any shortcut you want. Here you write any at this moment uh, address. So say http foo.com slash onto slash mine. Raise a flag when you're done. You have a computer here. I saw it. It's okay. You can parse it even mentally, but use this opportunity. We'll pause recording. So then go to this easy RDF converter. So easyrdf.org/converter. So you can Google RDF converter. That would be displayed as a first hit. And what we do here, we convert, well, that's what we do manually. So all the parsers do it automatically, of course, if they see N3 notation. But first, what we do, we convert it to our to serial format. Say if you had some errors. I did have an error using the wrong symbol for quotation. And then you can take this XML version of RDF and go to the first tool, which is the validator. And in the validator, so you hopefully now you can parse it. Yeah. Why does it display only? Does it display all the entries for you? Convert. Let me see. So what's RDF description? Blah blah blah. RDF about blah. Uh, mm, Let me try the following. So and then I will. Let me see. Guess RDF. So let me convert it first. Submit. Okay, so that's a bit better. So now what we shall see is okay. I would need to compare the generated. Yeah. What I did now. So and maybe you can try it as well. So can you try it as well? So this is the same set of statements as here, but the last two statements are now combined into a single one. Offline I need to check the result of conversion. They should be identical. So the previous one, the previous statement and this one, but this somehow parses correctly. So if you take this description and paste it here into converter, so then it generates this XML, which makes sense because so here it's the subject, and it is all about um, me. So has gender, has mother, um, is fun of, and etc. etc. Let me just. I mean, we still have time. I'm very curious. So what went wrong here? What went wrong here? So if I take this one. Uh, Submit. So what's wrong? Has gender, has mother, is follow. It should be identical somehow. Let's see. So if I go back, it should be pretty much same description. Nee. Parse. Yeah, okay. So I don't know what went wrong in the first time, but apparently it works even this way. Uh, right. So now what we will do as the last micro exercise. So I will demonstrate. This the effect of white space. Or blank space. So we expand or extend the story with a property that I have another hobby, uh, but which is the hobby of somebody else. So I'm not specifying this property as a terminal symbol, but rather I say take the hobby of somebody else. And in this way, so I don't know yet. So what this hobby is? So when I describe it, it is a variable in this case in the object part, and it means it needs to be expanded. So where this value should be taken from. Um, and here is the format. So now what was changed since the last attempt is that I specify this last property. So it's a subject me uh, is fun of predicate, and now so I take I say take the value for the hobby from um, somebody else. So in N3 format, uh, it is written in this way. So you use commas to iterate through the object part, and then the last statement you should use a variable. So let's see how it looks, and it will become evident when you see it in a graph format. So first I want to convert it to XML, and then let's study it. Or maybe I should have just expanded. So this was the previous one, and I just expanded with another statement, which was what was it here? Mm-hmm. Submit. At least it parsed without errors. And here is the stuff. So it's spelled out. The first two is fun of. So these are the terminal symbols, the objects, the values. And the last one is becomes a resource description in itself. So take something which is hobby of the this resource. So it means that so it's an it means that somewhere in this ontology there is a description of hobbies. And a property of hobbies could be belongingness to a specific individual. So the parser later on needs to locate it and substitute during the inference and substitute to the variable part. So let's see how it parses. Oops. Okay. So you see already on the triples format. So the last one it creates a placeholder, so kind of for a variable. So it doesn't know what this is, but it links it to the property of this object that is that exists in another ontology. So and graphically, it is visible like this. Let me just expand it, kill it. So this is me as a resource. So some properties are defined in my ontology. Some uh, property or values are taken directly because I from the other ontology. And this is a query type of relationship. So you need to later on resolve and put it in the in place of this variable. And this is the meaning of this brackets. And again, so today I will finish the class today. So we will not start RDFS because it involves some more complex relationship. So we talked about primitive way of describing knowledge in the form of atomic statements. So that the resource has a property and the value of this property. A value of this property can be either a value or another resource somewhere. So we introduce the notion of a file or a storage place which contains all these definitions. And this is so these definitions should be explicitly referenced to. So this is our semantic contract when we communicate between parties, and they are called ontologies. But essentially, they are just XML files structured in a certain way, where presumably all these definitions that we are using are present. And so today we talked about this triple format. So it's a plain resource description framework, RDF, and introduced the abbreviated notation, so N3, for a compact representation of such statements. So next time I will go into extension of RDFS, which would allow hierarchical representation of hierarchical knowledge. So that's, for example, my mother or me. I am a male, but male is a property of a human. So we will create a hierarchical structure. Okay, so that would be it for today. So a bit earlier. We'll finish. Any questions? Anything regarding labs, or feel free to ask. So then I close Zoom if there are no further questions.